Hi everybody, welcome to a new HDDWF repair video. Some time ago I've got two not working Atari Asteroids Arcade PCBs. If you haven't seen the first video about them, I suggest you to first watch that one. A link to it is in the description. Today I'll show our repair process needed to completely restore one of those boards. It's the newest of the two, a -04 revision. It is hard to read, but this was tested at the factory on June 26th in 1980. There is also what seems to be a serial number written by hand. It is a bit more than 148,000. Before continuing, let me introduce the sponsor of this video, JLC PCB. I have realized many of my projects with JLC PCB. They make good quality PCBs at amazing prices. Whether you are a hobbyist or a professional electronic engineer, JLC PCB can suit your needs for fast and high quality PCBs. You can use your favorite design tool and submit the Gerber files on their website. Or you can use the online design and simulation tools that are very convenient. Or you can simply submit the design files of any shared project. And after that, you just get the PCBs delivered at your door. So be sure to check their website for latest prices and offers. The link is in the description down below. JLC PCB, recommended from a long time satisfied customer. After completing a power supply for the game board that I described in a previous video, I tried to power up the board looking at the X and Y deflection waveforms on the oscilloscope. However, our outputs look completely flat. The first thing to check then is the CPU output clock on pin 39, and it seems okay. Next is the reset signal on pin 40, and this is stuck low, so something is wrong. Now I thought I had recorded some footage where I show that I measure with a multimeter a short circuit between the reset line and ground, but something went wrong while recording that. However, having found that something is shorting this line, it's time to go to the schematics. The reset line is driven by UD4, but any other IC that's getting this signal on any of its inputs could be shorting the whole line. So we first must go through all the schematics and make a list of every pin connected on this reset line. I have cut and pasted all IC connected to the reset line in a single image. They are UE6 pin 9, UD4 pin 8, which is the driver, UC5 pin 1, UN11 pin 1, UD8 pin 1, UA9 pin 11, UN7 pin 1, UM10 pin 15, UP7 pin 1. Now the idea is to check with a good resolution ohmmeter each of these ICs for resistance between their reset pin and their ground pin. The lowest reading should indicate the shorted IC. However, I've got two similar values on UC5 and UE6, so I decided to use better tools to identify the problematic IC. I use the HP456A logic pulser to inject current pulses on the reset line. Then I use the HP547A current tracer to see through what the IC is the injected current flowing to ground. For this test, the board will not be powered on. First, let's activate the pulser and connect it to the reset pin of the CPU socket. Now I calibrate the current tracer sensitivity to light with the full current that the pulser is injecting into the shorted line. Almost all the current will flow through the shorted IC. Then I start looking at the suspect IC pins. Until I find the one where the probe lights up. The short was on UC5, and since I'm now sure it's dead, I can cut all the pins and remove them one by one to reduce the risks of damaging the PCB. Then I have added a socket and put a new 74LS161 integrated circuit on it, so I'm ready to power up the board again. Unfortunately, the reset pin is still stuck low, so there must be another fault. Measuring again the resistance between the reset line and ground gives about 30 ohms, which is still too low to be good. To search for the new fault, I first need to recalibrate the current tracer. Now it is UD4 that is getting all the current. UD4 is the IC driving the reset line, so it makes sense that it failed too when it started to drive a shorted line. I have cut all its pins and removed them from the PCB. I've then soldered a socket and installed a working 74LS74 that happens to have an unusual chip code of some equipment manufacturer. And this time the reset line works, as it starts low, then goes high. And the game board works. This is the attract mode of Atari Asteroids. However, during the game modes, we can see that some asteroids are flickering, and some of the text displayed on the screen flickers too from time to time, so there is still some work to be done. After a few hours probing signals, looking for any hint about the flickering fault, the board started acting up on the Y deflection, as it can be seen here where I show the test mode screen. The correct test mode screen should instead look like this. When there are missing parts and repeated patterns, it is probably due to some stuck or missing bits in the Y digital to analog converter IC, or simply the DAC IC. Also, pressing the PCB in the vicinity of the Y DAC would momentarily give the correct screen. This is the Y DAC schematic part. As we can see, it has 10 input lines numbered from 1 to 10. The lowest bits, from 1 to 8, come from UB10. The bits 9 and 10 instead come from UF10. So all I need to do is to check the proper continuity on all these 10 connections to find the missing or intermittent ones. And yes, bit 4 looks definitely unconnected. Now, the YDAC is one of the few chips that had been replaced or just socketed during a previous repair attempt. Turns out that this job was a particularly bad one. We can see a few cold joints, a few missing pads, and a broken trace, all on the same IC. So I removed the previous solder, redo all the pin soldering, and I bridged the broken trace with a piece of wire. The test screen now looks correct again. Of course, there is still the vector flickering problem. The flickering is particularly evident on some of the test lines that are displayed on the high score name input screen. To make a very long story short, I've looked at the vector machine logic for hours, probing signals, but everything always looked correct. Then, out of desperation, I remembered that this board originally came with a 1 MHz 6502, but since this game has a 1.5 MHz CPU clock, I decided from the beginning to use a working but unknown and MOS 6502 that was donated some months ago. My reasoning was that this rebadged CPU was probably a recent and MOS one and probably was at least a 2 MHz part. As strange as it may seem, when putting back the 1 MHz Rockwell 6502, the game behaved correctly. As you can see, no flickering anymore. To confirm the problem it's really due to the CPU and not some hidden fault in the game PCB, I put the unknown 6502 in the other Asteroids PCB that I'm repairing. This one had still a fault in the audio thump generator, so it just makes clicks instead of the usual thump sound. Even this board, we can notice some characters flickering and some rocks flickering too, as it happened on the other PCB. All the other 6502s that I have worked fine. I've tried MOS technology, Rockwell, Signertech, and even a rebadged 65CO2. This is indeed a very strange issue, but I think the CPU works fine, otherwise it would not run the game and probably crash often. I think the issue is likely due to slow edges on either phase 2 clock output or the read-write output, or maybe both of them. I decided anyway not to spend time investigating further this issue for the moment, as I prefer to progress all the other projects that I have ongoing. The last troubleshooting step is to check that all the game inputs are working correctly. In particular, the thrust button input that should also produce the correct sound. Then the hyperspace button and the loud sound was the cabinet slam input. This board now works fine. I don't plan to keep this one for myself, as I prefer to keep the other one, which is the oldest of the two. I would like to swap this one for a same era Space Invaders arcade board, so if anyone is interested, please contact me. I hope it was an interesting repair video and that you learned something. If you have any question, please use the comment section below. Have a nice time and thank you for watching.